All right, answers to review for test 4. Problems number 1 and number 2 are absolute extrema. Remember that absolute extrema can only occur at critical points and endpoints. So to get critical points, I need the first derivative. So derivative of cosine is negative sine. Derivative of negative x is negative 1. Set it equal to 0. I move the sign to the left. Sine is negative 1 at x equals 3 pi over 2. So then we need the y values for the endpoints and the critical points. Plug in 0. Cosine of 0 is 1, so 1 minus 0 gives me 1. Cosine of 3 pi over 2 is 0, so 0 minus 3 pi over 2 is negative 3 pi over 2, which is approximately negative 4.712. 2 pi, cosine of 2 pi is 1, so 1 minus 2 pi is approximately negative 5.283. So our absolute minimum is 1 minus 2 pi, and that occurs at x equals 2 pi. Our absolute max is 1, and that occurs at x equals 0. Number 2 requires quotient rule, so bottom derivative of the top minus the top derivative of the bottom over the bottom squared. Don't forget about the bottom squared. Usually on quotient rules, if you guys screw it up, you guys usually forget the bottom squared. And I would also, especially on the top right, put stuff in parentheses. That way you don't forget to distribute the negative. So negative 1 distributed to the left is negative x squared minus 3. Multiply the 2x and the negative, we get negative 2x plus 2x squared. So that ends up giving me x squared minus 2x minus 3 on the top. Set that equal to 0. Set each piece equal to 0. When the top is set equal to 0, I can factor that, and I get 3 and negative 1 for my critical points. Set the bottom equal to 0. That does not produce any critical points because it's impossible for x squared plus 3 to equal 0. Plug in the endpoints and the critical points, so we get 3/7, 2/4, negative 2/11, and negative 3/19. And I showed you their approximations over here. So our smallest value is negative 0.181, which is negative 2/11. So that's our minimum. It occurs at 3. Our biggest value is 1/2, and it occurs at negative 1. All right, number 3 we did in class, so see that video. Number 4, I don't believe we did that in class. So we need an equation of a tangent line at its point of inflection. So points of inflection come from the second derivative. So I need the first derivative, which is right here. I need the second derivative, which is right here, and set that equal to 0. So we get x equals 1. I want to verify that it is a point of inflection, so I need to make sure my signs change. So I do a sign line, and when I plug it into 6x plus 6, we see that's negative on the left, positive on the right. So since the signs change, that means it is indeed a point of inflection. So if I'm going to write the equation of a tangent line, there's 2 more things I need besides the x value that I already have. I need a slope, and I need a y value. So we get the slope from plugging into the derivative. So I plugged into the derivative right here. We got a slope of negative 3. I plugged into the original function to get my y value. My y value is 4. So y minus 4 equals negative 3 times x plus 1. Clean that up, and we see that the answer is B. All right, number 5. We want to figure out when the graph of f is concave up. Remember, concavity comes from the second derivative, where the second derivative is negative. So I'm going to take the first derivative, which is right here. I'm going to take the second derivative, and I set the second derivative equal to 0. I factored out 60x, which gave me x squared minus 2. Set both of those equal to 0. The 60x is going to give me 0. The x squared minus 2 is going to give me the plus and minus the square root of 2. Put those on the sign line and plug in. We have negative, positive, negative, positive. Again, it's interested in concave up, so that means where we are positive. So we're positive between negative square root of 2 and 0, and greater than the square root of 2. So that's why my answer is B. Relative maximum, we get that from the first derivative. You can use the first derivative or the second derivative test. In this case, I'd probably just go with the first derivative because it's easy to do the sign line. So first derivative is going to require the product rule. So first times derivative of the second plus the second times derivative of the first. Both of them had an x minus 3, so I factored that out. That left me with 2 and x minus 2, so that's where the 2x minus 4 comes from. Over here, I'm left with an x minus 3, so that's where the x minus 3 comes from. Put my like terms together right here, I get 3x minus 7. So 3 and 7/3 are my critical points. Put those on the sign line. Positive, negative, positive. We want a maximum, so that occurs where we change from positive to negative. And so that means negative, or 7/3 is where our maximum is going to occur. All right, we worked number 7 in class, so see the other video if you want to look at number 7. We did number 8 in class, so see that video if you want number 8. I believe we looked at number 9 as well in class, so see the other video for number 9. We looked at number 10. We did not look at number 11, so let's look at number 11. Critical points of f. We're looking at the graph of f prime. So here's the graph of f prime. Critical points are going to occur where we're touching the x-axis or where the graph of f prime is undefined. So in this case, we have b, d, and f because f prime is 0. Relative extrema. Relative extrema, remember, can only occur at the critical points, so only at these 3 spots right here. So I need to know, am I changing from negative to positive or vice versa? At B, I'm changing from negative to positive, so that means I have a minimum. I'm also changing from negative to positive at F. So B and F, I have minimums because F prime is changing from negative to positive. At D, however, F prime is changing from positive to negative, so that means we have a maximum because f prime is changing from positive to negative. Points of inflection. If I'm looking at the graph of the derivative, points of inflection are going to occur where the derivative changes from increasing to decreasing or vice versa. So we're going from increasing to decreasing right here at C. So that's why I have a point of inflection there. And we're going from decreasing to increasing right here at E. So that's why I have a point of inflection there. We want intervals where f is decreasing. F is going to be decreasing where f prime is negative. So f prime is negative right here between A and B, and it's also negative between D and F. So that's why we chose A and B and D and F. And the intervals where f is concave up. If I'm looking at the first derivative and I want to be concave up, then that means the first derivative has to be increasing. So we're increasing from A to C and from E to G. And that's why we are concave up on those intervals, because f prime is increasing. Remember, if f prime is increasing, then that means the second derivative is positive. And if the second derivative is positive, then that means we are concave up. All right, number 12. We talked about number 12 in class. Number 13. We did number 13 in class as well. 14, we did not talk about 14. 14 is a second derivative test problem. It says f is twice the differentiable. It says g of 6 is negative 2. It says g prime of 6 is 0. And it says g double prime of 6 is 5. So the fact that g prime of 6 is equal to 0 means we have a critical point at x equals 6. And the fact that g double prime of 6 is 5, which means it's positive. Because it's positive, then that means we're concave up, and that's why we have a minimum. So relative minimum at 6 is negative 2 because g prime of 6 is 0. And so we're establishing the critical point right here, and because the second derivative is positive. We talked about 15 in class. 16. We're looking at L'Hopital's rule. So the number 1 rule is to plug in. When I plug in 0, I get 0 over 0. So then we need the derivative of the top and the derivative of the bottom. So the derivative of the top would be 3 cosine of 3x. Don't forget to take the derivative of the inside. And derivative of 7x is 7. And derivative of 5x is 5. So we plug in again. Cosine of 0 is 1, so that makes that 3 plus 7. So 3 plus 7 gives me 10. There's nothing to plug into on the bottom, so it stays 5, and 10 divided by 5 is 2. So that means this limit right here is equal to 2. We did 17 in class, so see the other video for 17. And we also did 18 in class, so see that other video. So there is your answers, all of your answers to review for test 4. Study up, and we will see you tomorrow.